In this video, we're going to talk about solving absolute value inequalities of the form less than or equal to. So we want to solve this absolute value inequality and write the final answer in interval notation. So let's figure out some numbers that make this inequality true. So let's put this on a number line. So we know 3, because the absolute value of 3 is 3, that's less than or equal to itself. Same argument for negative 3, because the absolute value of negative 3 is 3, and 3 is less than or equal to 3. So what other numbers can I plug in? Well, 0, because the absolute value of 0 is 0, and 0 is less than or equal to 3. 2 and negative 2 are a couple other possible solutions for this, and everything else in between. So I've shaded the region. So what do you notice about the solutions? Well, the values certainly have to be less than or equal to 3, but also the values also have to be greater than or equal to negative 3. Both conditions must be met in order to be a solution here. Okay? So notice, when I have the absolute value bars by themselves, and I have a less than or equal to, I will have an and statement, or in other words, an intersection. So, how do I write this in general? If I have the absolute value of ax plus b is less than or equal to c, then I have two inequalities. Ax plus b is less than or equal to c, and ax plus b is greater than or equal to negative c. So every time I have an absolute value inequality, you should expect to have two inequalities. Okay, so let's solve the absolute value inequality, then write the final answer in interval notation. Now, before anything else, I must get the absolute value bars by themselves. So I'm going to subtract the 1 first. And now I'm going to divide both sides by 10. I don't ever want to distribute a number inside the absolute value bar, so I will always divide here. Now, the absolute value bars are by themselves, and it's a less than or equal to sign here. It's an and statement. So let's write them out. X plus 3 less than or equal to 2, and x plus 3 greater than or equal to negative 2. Now, notice, once you write these two inequalities, the absolute value bars are gone. So solve each inequality. Subtract the 3 and subtract the 3. So now I'm going to graph each. I'll start with x is less than or equal to negative 1. Now I'll do negative 5. Now remember, with an and or an intersection is where they overlap. So it's this region here. Well, it starts at negative 5. Negative 5 is a solution here and here, so it's a solution here. It goes as far right as negative 1. It's a solution here, and it's a solution here, so it's a solution here also. All right, let's do the next example then. So again, I need to get the absolute value bars by themselves. I'm going to add the 3 first. Divide by a negative 2. Now remember, when you multiply or divide by a negative number, you must switch the inequality sign. So now notice, now the absolute value bars are by themselves. We have an inequality symbol of less than. This is again an and statement. So let's write out the two statements. And let's solve each inequality. All right, let's graph each inequality. Now remember, again, it's where they overlap. So it's this region here. All right, so 2. Now again, 2 is not a solution here, so it's not going to be part of the solution for the intersection. we can go as far as 3. 3 is not a solution here, so 3 is not going to be a solution to the intersection either. Remember, we do not make decisions about and or statements until the absolute value bars are by themselves. Okay, one other example. Now again, the absolute value bars are by themselves. It's a less than or equal to. That means, again, is an and statement. So let's write them both out. Okay, so add the 4, divide, and the same thing here.